Hello, everyone. I am Francis Friedlander from IBM. I saw a few names, so a few of you know me. You can see my email address and LinkedIn URL at the bottom of this slide. You are going to get the slides, so feel free to reach out if you want to continue this conversation, indeed on a very interesting topic. So in my role, I am helping clients across Europe to address complex business problems when it comes to automate decisions or the decision-making process. The topic I'm going to present to you today is really new material, and it's almost new concepts. But actually, these concepts germinated when I was working with a large health insurance and health provider. The business problem they were trying to address was to decide on the fly how many doctors to staff in urgent care units, taking into account the context. And by context, I mean how many people are waiting in the rooms, what day of the week is it? Is it Monday, Tuesday? What's the month? Is there a flu epidemic or is there a heat wave, etc.? So what we did is somehow similar to what I am going to show. We built a simulation model that mimics how a hospital works with a pool of doctors. When a doctor is busy, patients have to wait, but when a patient leaves, the next patient can see the doctor, etc. So the simulation model mimics the hospital, and the machine learning model is generating a distribution of patient arrivals. We presented this topic at the Think conference, and if you are interested, send me an email and I will send you this presentation. So this is a good illustration of when we collaborate with people from different industries, some nice ideas can come. So again, if you're interested in talking these topics, feel free to reach out. So the business problem we are talking about today is how can I build a car insurance model, or sorry, a car insurance pricing model that is at the same time transparent, so that I can explain each pricing decision to a client, but also improve this model, and at the same time sustainable. So by sustainable, I mean I am not losing money with this, right? So you have to take into account the price. You have to take into account whether the clients are going to buy at this price. Are the clients going to file some claims? And if so, what is going to be the amount? So this very complex, this very complex combination can be run in simulation. And at the end of the day, you aggregate for all the clients and you can predict whether this insurance company is going to lose money or not. So as you will see, we are going to use machine learning techniques to build predictive model to answer these questions. So let me first introduce this concept of business rules. So when you have to make a complex pricing decision, you have to take into account risk, you have to take into account regulations, you have to take into account also commercial things. So for example, what you can see on screen is a commercial boost rule, which is going to apply a discount on insurance products in a few countries, Austria, Czechia, etc., for Ford, and I would say for cheap cars. So at least cars with a price less than 31,000. So this is really a business decision. This is something you want to put in place to boost the business in this particular line, I would say, a segment of the business, right? So as you can see, even if you are not a car specialist or an insurance specialist, you understand exactly what this rule is trying to do. So it is transparent. It is transparent and it is also traceable, meaning when you make rule-based decisions, you can explain each individual decision on each case in terms of business rules, right? And also, the rule base is auditable, meaning when you change business rules, you can figure out who changed the rules, what the change was, etc., etc. So transparency, but also agility. These rules are easy to change, and you don't need to be an IT person to change the rules. And also governed, meaning there is a process to do these changes. So if you compare machine learning and rules, this is something many people are trying to do. I think the first very important thing to say is that machine learning is not meant to decide. It is meant to predict or to classify. So predict, for example, how likely is it that this client is going to leave my bank, or classify, is this a good client, whatever. So the very interesting thing about machine learning is that it learns, or machine learning models learn from data, right? And you do not need actually to deeply understand the underlying business model. I mean, you don't really need to understand the business mechanism, what is the causality, etc. You are really interested in how this translates into the data. So it's more a mathematical discipline. Business rules is a bit different because you really need to model your decisions. And the purpose of business rules is to capture, to document, and to automate expertise. And as I just showed, business rules are really transparent. And on the other hand, machine learning is not that transparent. So some algorithms, such as linear regression or logistic regression, this type, are still transparent. But when it comes to neural networks, etc., it is not transparent anymore. You cannot explain why this, for example, this image was tagged as showing a cat and not an elephant, right? You cannot explain these things. So both actually are really very powerful approaches. So how to combine them and take advantage of what they are really best at? So there is already an approach which is extremely powerful, extremely successful, which actually is also going to be one of the key, I would say, elements in ADS. So this is something new the lab is preparing, and Pierre is going to tell us a bit more about this. So actually, if you look at the rule which is here, you can see that you are making the decision based not only on what you know about the client, the country, or what you know about the car, whether it's a Ford or a Fiat or whatever, the price of the car, the line of business, but also things that you are predicting thanks to machine learning. So the probability that the driver is going to file a claim in the next 12 months, if this parameter is less than 10%, you consider that this client is not risky. And so you use machine learning to make such prediction, right? So this pattern of injecting machine learning predictions or classifications in business rules is extremely powerful. Somehow you get the best of both worlds. The drawback is that it is still a little bit black box magic, because if you are trying to explain a client why this client had 4% and not 5% reduction or discount, You will tell, okay, because your probability to file a claim in the next 12 months is less than 0.1. And the client is going to tell, but how do you know that? So there is still a level of black box magic in this combination. But again, it is extremely powerful, and more of our clients are using that. But there is actually another approach, which I'm going to propose today, which is actually to take advantage of machine learning and business rules in the following way. So you make decisions or rule-based decisions based on criteria which are really factual, right? It's not things you are predicting, it's things you know about the client. Then you run some simulations, and those of you who use ODM, for example, know precisely what simulation is. I will show this, but you simulate the business impact. This is something I would say business as usual. But what can be very interesting is that you can augment the business data you use in simulations with machine learning, right? And this is exactly what I want to show you. So first, let me show you on an example what a simulation is. So if you look at a decision service, which is going to determine what price you are going to propose for a car insurance to a client, okay, it's simplified, but you could say that there are two phases. First, you are going to calculate a price based on the risk. And second, you are going to apply some commercial boost rules. And maybe at the end of the day, you are going to lose money, but you are going to gain some clients, etc. So this is very complex to determine whether this is sustainable. But at least this shows how you could make your pricing decision. And now if you zoom on risk-based pricing, there is one part which is calculating the risk for the client based on the car, which type of car is it, also based on the driver, did the driver claim in the past, etc. And so then based on this risk assessment, you calculate this risk-based calculation, right? So far, there is no machine learning. It's only business rules. And here you can see two artifacts. The first one is a business rule expressed in natural language. And ODM supports up to 15 languages. So you can write these business rules using business terms in natural language or pseudo-natural language. And you can also have some decision tables. So for example, that one is going to determine, given the make of a car and how much the car costs or how much it cost when the client bought it, some parameters that are going to be used in the price determination, right? This is fairly easy to understand. All this is transparent, as I said previously. So in our, I would say in our economy, what is key is change, agility. And so one of the main purposes of the business rule approach is to make this change as sustainable as possible. So question number one, what is the impact of the pricing model on the revenue if I change the business rules? So for this, we have this capability called simulation, where you are going to take some real data, and it is very important to take real data because it represents rather well what is going to happen in the future, several 100,000 or million cases. And here I show them in Excel, but it could be in a database with what you know about the client, the age of the client, etc. So for each of these cases, you are going to calculate the price based on the business rules before and after the rule change, and you are going to compare the impact on some KPIs, right? So for example, what is the total revenue by line of business? So as I said, ODM is all about changing the business rules. And I mentioned auditability. When you change the business rules or when you change the decision tables, you can really figure out the delta. Who made the change, when, for what reason, etc. So this is very important if you want to have governance on your business models. And in the same way, you can run the simulation before and after changing the rules, and you can figure out what is the impact on your total revenue. But if you are deciding, for example, if you use business rules to assign work to people, how many people are going to be overwhelmed with work, etc. So this is really a very powerful tool, these simulations. So let's now have a look at simulations from the perspective of data science. So what you can see here on the left-hand side, the horizontal axis is one of the input columns. What is the initial price of the car? And the vertical axis is the price that the business rules decided. So of course, business rules are deterministic, so it should be a curve, but there are many hidden dimensions, for example, the age of the driver, etc., which I did not show. So this is why you have a cloud. But anyway, when you change the business rules, you change the shape of this cloud. And so on the right-hand side, you can see what is the impact of the rule change on the price that you are proposing to the client. You can see there is a change. And so the key question, if you want to make sure what you are putting in production is sustainable, you would like to know what is going to be the impact on revenue. So one very naive approach would consist in taking all the quotes that were made for the clients with the old rules, and you run again the same input given by the client with the new business rules, and you compare. But it is very naive because many clients did not buy this, did not accept this price. So it does not reflect your revenue. So there is a much better approach consisting in taking into account, in filtering out all the clients who did not accept, and you keep only the clients who accepted. And this is this blue cloud you see on the left-hand side. So you see the amount the clients paid, and if you sum all that, you do an integral calculus, you have exactly what your revenue was. And if you want to predict your revenue after you change the rules, so you could decide, let's take all the clients who accepted, I calculate the new price, I sum, and I get the new revenue. But this is not really true because, if you look at this blue pricing decision that was made, it is blue, so the client said, yes, I am okay. With the new policy, it is above this line. So this line is like a tipping point above which the clients do not buy. So probably this client is not going to accept. So you should not include this one in the revenue. And the other way around, if you look at this red, he refused, but with the new pricing policy, maybe he will accept, right? So this would be also a naive approach. In the same way, if you multiply all your prices by 2 and you run a naive simulation, it will tell you, excellent, I doubled my revenue. But things do not happen like this, because if you double the prices, many people will not buy, right? Here it's a bit more complex because some prices go down, some go up. So we need to be a bit more intelligent, and this is where machine learning enters the scene. Looking at this data, we figure out that there is this tipping point above which clients do not buy and below which they buy. And this is actually a classification problem. And so this is fake data I generated for this presentation, but assuming this is real data, a good way to address this would be a logistic regression, right? And so by applying this logistic regression, you would then, on the changed cloud, color in red, you would color in red those who would refuse the new pricing. So it's quite interesting because you run the simulation on the same data, but you are not taking the same individuals into account. So for example, if you compare the simulation before and after, you can see that you are not taking the overall population is the same one, but the blue population is different, right? And so the idea here is to train this regression model. And once we have this regression model parameters, we inject them back into the simulation. And it is great because logistic regression can be easily expressed with actually a linear expression. So you can inject this. And I don't have time to show this to you, but I did it in the demo. We have ODM running this simulation working on two different populations. Okay, so this addresses the first question, which is not specific to car insurance. What is my revenue? But where it becomes much more interesting and specific to insurance, am I going to lose or not lose money at the end of the day, taking the risk into account? So the first question we have, is it likely that this particular client who is going to buy is going to file a claim during the duration of the contract? So here, a disclaimer again, I'm not trying to address a machine learning problem. I'm not trying to come with a machine learning or data science algorithm which is robust. I'm trying to explain how you can smartly combine business rules and machine learning. So the machine learning models you are going to see are simulated, right? I mean, the data, I generated data specifically, but actually, if you are interested, you can find some claim data on Kaggle. I tried to work on them, but it was too complex. Also, I tried to have data simple enough so that the machine learning model is either a logistic regression or a decision tree or random forest, etc., so that I can easily reapply it in Java. Later today, Pierre is going to present to us how you can actually invoke any Python, or any machine learning model developed in Python from Java, right? So this is going to be the step 2 of what I'm showing, but it's a work on the, it's still under construction, I would say. Okay, so this is data I generated, but assume this is how clients reacted, right? So green is the green is they did not claim in the past year, and red is yes, they claimed. So this makes the assumption that actually all the drivers and all the cars generate more claims. It's just an assumption. And here again, the assumption is that this is well modeled with logistic regression. But here we are not going to use logistic regression to classify, because you cannot say this client is going to have an accident, this one is not going to have an accident. You cannot guess these things. But we're using this to predict what is going to be the probability that this client is going to file a claim in the coming year, right? So what you can see here, this is the sigmoid or the logistic curve. By doing a linear combination of the age of the driver and the age of the car, you can somehow predict what is going to be the probability that this client is going to file a claim. And this is important in a simulation. Okay, and the last question is, assuming the client is submitting a claim, what will be the amount? Because at the end of the day, you want to compare amounts you have paid in claims versus the amount you got in people buying the insurance products. So on the left-hand side, this is still the red points, meaning all the clients who filed the claim. On the right-hand side, you have a color coding from blue to magenta, showing how much it was. And so, sorry, from magenta to blue, I should say. And here it's interesting because younger cars and younger drivers actually lead to less claims, but the claims are more expensive because people drive faster. So when something happens, it's a bit more expensive, right? And so here the approach was to generate decision tree regressor or regression model, which you can see differently here, because once again, this is very easy to put back in ODM. And so you have a way to run this simulation, these simulations completely. And at the end of the day, you really know what is going to be the profitability of each individual client. Of course, you don't want to reject or accept on this basis because you want to have a macroscopic acceptation policy. But at the end of the day, it's going to tell you, if you aggregate all that, whether your model is profitable or not. Okay, you are going to get this.
Francis,
yes,
just for you to know, you have 5 minutes left.
Oh, but I'm actually finished with the presentation, so maybe we can have a look at the questions. So the one thing I want to tell is that you are going to get these slides with links, right, and my email coordinate, etc. So maybe for the sake of efficiency, Sébastien or Pierre, have you seen any interesting question you would like to raise?
So in the WebEx chat, I saw a question about the transparency and explainability. So I answer that we intend, let's say, we consider, let's say, the readability of the business logic when we talk about transparency and explainability. So there are very vast themes, but this is, let's say, we want to show the rules, or let's say the business logic, and whatever you are a data scientist or let's say a developer, it's right, but we want to bring an explanation to a business user.
So are there questions you did not answer?
So in the WebEx chat, I have not seen other questions so far, but maybe I'm missing something.
So back to this point. Sorry, please go on.
Yeah. There is a question from Carl. How do you consider the survival of bias when simulating your claiming data?
Okay, so I have to admit I am not a data science expert. So what you don't want to use this machine learning approach to make each individual decision, right? This is something we excluded from the very beginning because, as Pierre said, we want to have total transparency. We want to use this on a more macroscopic scale at the end of the day to decide if this model is sustainable. So I would say that bias somehow is hidden.
I think, Francis, the best is I will ask Carl, who's the person who asked the question, to ping you
good.
Directly per email to have an answer, because we don't have more time than expected.
Sure.
Okay, superb. So I'm going to switch the focus onto the Pierre presentation.
Great.
Pierre, I'm going to. You should be able to share your presentation, Pierre. Thanks a lot, Francis, for this for your presentation. For everyone on the call, if you have any question for Francis or if you want more information, please feel free to send an email to him. I think he will answer with pleasure to all of your interrogations. Pierre, you should be able to share your screen.
I should, yes. So
thanks. Okay, working.
Okay, good. So, welcome, good morning, good afternoon. So my name is Pierre Feillet, and I am decision automation, not optimization architect. And so I am based in France as Francis. Okay, so let's dive into decision automation and decision automation with AI, meaning with ML and with data. And I will have another perspective than the one coming from Francis, even if we agree, let's say on the core concepts. But so as a product architect, I have let's say a different set of activities. So I work with customers mainly in the financial services for major banks and insurance companies, including in Europe, US, and Asia. And I am in charge of a few releases of the product ODM and some other decision automation capabilities coming in the IBM portfolio. So for the decision automation use cases, we apply decision automation usually in loan processing, claim processing. We have customers like PayPal, MasterCard, who are using our technology every day in production to automate the processing of transactions in eGov and education as well. So we see use cases and retail. So you have some retail companies using decision automation for pricing, for loyalty programs. So we have customers, for example, for in casino business, even if today this business is rather low. So insurance, yes. Travel and transportation, so invoicing, once again, loyalty. Healthcare, we have a use case at the NHS in UK to match the organ donor, let's say, transmissions, and see if, let's say, what are the best matches for the organs. And manufacturing, we have use cases as well in the decision automation. So zooming into a few of this decision automation use cases, we see, for example, product recommendations, underwriting decision, and so on. And we start to see side by side what we can accomplish and what, let's say, accomplish today our customers with machine learning and with business rules. And so basically what we do with machine learning, as introduced before by Francis, is that we are scoring, we are estimating probabilities, risk and opportunities. So we score how likely a customer is to buy a product, the likelihood of a customer to churn, of a fraud, of a default on payment for a loan, and so on. And for the business rules, what we usually do is that we ensure the eligibility in a pre-approval or an approval process. And so this eligibility is based on the regulations, business policy. So they are coming from the human expertise, and there is a compliance. So usually when you have to respect these regulations, there is, let's say, a drawback if you are not, let's say, in this compliance when you do your business. So the business rules are used for this eligibility to implement business policies for booking, investigation level, and so on. I go quick on that. So machine learning, and there are many ways to present or to introduce machine learning. Basically, what we do with the traditional programming is that from the inputs, and yes, we process with a program, and it means that we have developers in the room who write this program based on the specifications, the requirements, and after specifications. And from when we run this program, so we go from the inputs to the outputs. With machine learning, the thinking is very different, because we say, okay, and here I zoom directly on the supervised machine learning. We know that we have inputs, and we expect to have outputs, and we don't want to program something from scratch, but we want to teach or to a kind of generic approximation program, and to tune it to approximate the expected outputs when there are new outputs that come when we are using this ML model. So the hub here is that we jump, let's say partially, or let's say for a big part, on the top of the programming phase, and with a kind of generic programs, just by feeding them with input and expected outputs. After they generalize well enough to approximate a right output with new inputs. And in the ML landscape, you have many families and then areas with the supervised, unsupervised, and you have very well-known algorithms that are in this field for years, like k-means, or let's say logistic regressions, and they are, let's say, classics. And neural networks are not new at all, and they are coming from the 60s, yes. But since 2012, there is a kind of a revenge of neurons, and there is a good article with this title, so The Revenge of Neurons, written by a French researcher. And the neural networks have made huge progress with more data, more compute, and as you have seen for the past years, we achieve, let's say, higher results with modern machine learning. So when we meet customers who want to progress in their automation journey, and this automation journey is one part of the full digitalization journey. So all the companies are increasing their digitalization. And when you start to get all the data, or more and more data digitalized, you can scan, for example, automatically your documents, and from pixels you can get text. And after, for example, for claims or for purchase orders, you want to automate and get the information that are structured from the beginning or coming from pixels. And you want to automate, for example, a purchase policy. So if my article has a price below this threshold and blah, blah, you want to push directly an action and increase the level of automation of your organization. So what we usually see in this journey is that we want to reduce cost. We want to reduce the time to market. And this is true for decision automation in general, and for the usage of machine learning. And one of the, let's say, weaknesses or bottleneck is the access to the expert to get the knowledge. So usually for the training or for any expertise, the expert has a limited bandwidth to explain how he organizes his business. And there is always a cost to formalize what can appear as an intuition or something that looks natural, but it's not, let's say, it's not formalized. So the writing of this business logic can be long. It can be expensive. There is always the life cycle to handle. So you can be good for V1, but how do you manage the changes 3 months or 3 weeks after? And this is true, let's say, even for ML or for rules, but there is this cost of maintenance in consideration. And let's say one of the news, let's say, in the recent years is that we have more and more data. So we have a kind of hope that with free or let's say low cost data, with low cost algorithms as ML implementations are in majority in open source, we can combine the two. And okay, we have compute at scale, including on cloud data centers. So we can scale, and at the end we can have very good approximations, and maybe so there's approximations to estimate the risk, to estimate opportunities, can do a difference in my business. The issue is that ML alone so may not be enough, as mentioned before by Francis, because ML so is good at giving classifications, regressions, but it's not directly good at reasoning or taking decisions. And for example, if you have a risk of a default for a loan repayment of 10%, this is your decision as an organization to set the level of risk that you want to accept, depending of your policy, depending of the level of competition on this market, and so on. So there are some elements of human expertise, human choices that you inject in this decision automation. ML is good at reproducing the past, and for example, in this COVID period, many ML models that have been trained in a kind of normal mode have been, let's say, totally out of their prediction spaces for the last weeks, because the conditions are not, let's say, nominal at all. And so there was a discussion recently on a rental of bikes in London. So, and if there is a lockdown, or if there are, let's say, not normal life conditions, you cannot expect to run as usual your ML model to predict what will be the logistics and what will be your business. ML needs good quality data and training, and usually, so yes, it's not so easy to have large data sets, and after it's even less easy to have good quality data sets. So it remains a challenge. ML is a black box or a gray box. So depending on the algorithm that you choose, if it's a decision tree, so decision tree, we can say, okay, it's readable for a human, but when your decision tree has let's say an important depth or a width, and let's say the cut conditions are very let's say numerous in your decision tree, it becomes very quickly hard to read. And when looking at the neural networks, CNN and so on, it's black box. And last is when you do ML, it means that you have skills, so data science skills, to understand how to treat the data, how to, let's say, pre-process them before choosing your ML model, train one or several models, make experiments, and after so go on the optimizations. And after, there is a full challenge in the ML ops or AI ops to deploy a V1 of your ML model in production, and after manage the lifecycle, the retraining when there is the accuracy of the models that goes down, and so on. So very quickly on the business rules. So business rules, they are coming from the expert system and on the symbolic AI branch. So ML and neural network, they are said sub-symbolics, and business rules are on the symbolic branch. And they are so we were talking about rule inference engine. And so with the approach is to model your knowledge, so with a kind of ontology. So what is a client? What is, for example, a card transaction? What is a merchant? What is a fraud in my system, and so on. And you are handling symbols or pieces of knowledge in your ontology, and you want to model how you decide when you have new inputs, a new client, a new transaction, and what are the decisions that you make, and you want to connect these decisions to into action. And checking the time. Okay.
You have 10 minutes left.
Yeah. So ML and rules, they have sweet spots, and very often we have heard that ML was replacing all the other parts of AI, including optimizations, and I disagree with that. And so here you have coming from DARPA, sweet spots of machine learning and rule systems. And the main part here is that rule systems are good at reasoning. So ML is good at getting predictions, and they are good starting from unstructured data. For example, to detect objects in one picture, and for this there is no sense to try to do it with business rules. On the other hand, if you want to implement a regulation, your business policy, your pricing, and so on, going directly in a deep neural network would be, let's say, bizarre, especially if you expect transparency, explainability in your decision making. So there are good spots, and let's say our point of view is that we should combine these different AI technologies together to automate decisions. So starting from the real world, so from pictures, from sensors, we can start by sense and get object detections, any form of recognition, starting from pixels and getting applying OCR, and OCR is not new per se. And from the structured data, we can continue and we can establish correlations with machine learning. So we continue with machine learning in this cycle. And then after we can decide and we can use the risk assessments, the opportunity assessments as scores or in other forms in the decision logic. And this for the decision, we can use rules, and optimizations can play a part as well. Based on let's say most of the client conversations that we had in the past years, is that you have a kind of split of the organizations between the data science part and the operational, the decision management part. So you have a data science or a data lab team on the left, and they have a data lake that is a copy or an extraction of the production database, and they can have a lag between the production date and the day that they see the new data coming in their lab and in their data lake. And so this team is very focused on data science. They are very, let's say, they are good at doing SAS a few years ago, more and more Python, and there was R between the two. And there is a trend to move on big data using Hadoop and MapR and Spark for large batch processing. On the other side, you see regulations, corporate policy strategies that the organization has to implement. And so in the two part here, so the data lab team gets insights. One part of the activity only, about 15% of the data science, can be transformed into something that will reach the production. The other part is just to get analytics, so descriptive analytics. And for the from the regulations, organizations are writing business rules or coding programs to implement these policies, and they are doing what we call prescriptive models. So predictive models on the left, prescriptive models. And what we see is that between these two parts of the organization, there is one or several gateways. And so the ML models, the predictive models, are sometimes translated. And this is the case, for example, at PayPal for some of the models. Some are coming directly and go to reach the production, but today, in my view, this is just a very small minority. And in some cases, from the predictive models, clients are building database tables, score, let's say, tables, and they are reading this score values from the production system. So this is one way to translate the predictive model into something that organizations and the IT can put in production rather easily. So we automate the business, we automate the decisions. Automation of the decisions is done, and it generates a database of transactions. And from the transactions, there is usually a feedback loop. But the feedback loop can so you can spend weeks, months in some cases to have a feedback to the data lab team in this cycle. Okay, super quickly. So when we mix business rules and ML models, usually what we do is that we have a business expression that is near a natural language expression. For example, if the client is at least 18 years old and is risk score, so is less than X, this threshold, then do something, take an action or take a decision. And the risk score here is coming from an ML model. So this ML model can be directly computed inside the rule engine, or it can be done remotely. And we have several solutions to make this integration happen between the rule engine and the ML algorithm. On the second example, when you see propensity to churn is high, so here you see two aspects to move from the ML level to the business logic level, because so we have to estimate the propensity to churn. Okay, so we can go on Watson Studio or any notebook to train a model and estimate the propensity to churn for a customer depending on his features. And after there is the I value. And so the I value, you can, for business users, define once that the I value is 20% or 50%. But here we don't expose this number, and this is something that you can do, and more. Let's say in the business logic stack, you can give abstractions and be let's say abstracted compared to the raw numbers that you have in the ML level.
Pierre, il te reste 3 minutes. 2 minutes, Pierre.
Okay, 3 minutes, so super quick. So good news is that today we have customers who are using in production a combination of business rules and ML. Of technical solutions, but today with the products that we have in IBM named DBS, or Digital Business Automation, you can mix business rules with ML. And on this picture, there is one pattern. It's through a remote call we are using Watson ML, but you can call any other ML as a service solution. And we get an ML prediction. And after we reuse this prediction into the decision making. And there are, once again, other patterns. More recently, we have shared for ODM customers, but it can be used, let's say, for any integration. An open source proposal.
You hear me? I lost the sound.
Yes, yes, it works.
Okay.
Go ahead.
Yeah. Okay. So recently we have published a new GitHub repo that propose a Docker-based microservice to host ML models. So this is very simple, but this is something that can help to prototype and to integrate business rules coming from ODM or something else with scikit-learn, XGBoost, or other algorithms. And you have the link. We are working currently on a tech preview for decision automation. And in a nutshell, we are using decision model notation. So you have a sample here on this page, and with a standard DevOps integration. And we are working on a kind of native integration from the rules expressed in this decision domain with the ML models coming from Watson or coming from what we call an open prediction service. Super quick, if you are interested by running rules plus ML on big data, this is possible. So we support Hadoop, and we have projects on another GitHub, and the link will be attached in let's say, will be in the press. I go super quick. In Spark, if you want to have a decision automation at scale, it runs well, and the rule engines are parallelized on your compute grid, multiple JVMs, multiple threads running in parallel. I go quick on this. Yeah, and in Watson Studio and in general in data science, you can get all your automated decisions, and we have a module named Business Automation Insights to capture all your decisions, and after we can apply any analytics, any descriptive analytics to understand what are your decisions, and the idea is to improve them into a V2 of your decision logic. So the links, wrap up. So you can combine today business rules and NML, and there is an interest to bridge the cultures of the two teams today. We are good to go for data science with business rules. And there are other opportunities on the cognitive part and on chatbot conversational agents that we don't have time to, let's say, to cover here in this presentation. And a few comments to end up with. So Python is the de facto standard for ML. So even if in the story we saw a presence of SAS and after R, today this is Python that prevails, and this is a good language, and this is very interesting to use. A large number of ML algorithms, so you can have fun by programming Python and ML models. And on the runtime, I see a convergence on Kubernetes, Docker, form factor. Whatever we are interested by online systems or by big data, I see that the two IT are converging in this direction. If you want to learn more about ML, if it's not yet the case, I recommend to follow the Coursera Andrew NG MOOCs. They are very good. And there is a good podcast, TwinML AI, that I listen often. And so my last word would be learn the maximum that you can and innovate. Thank you.
Thanks a lot, Pierre. Learn and share, and we are sharing today. So thanks a lot to you, Francis and Pierre, for your time. There is question in the chat, but as we are constrained by the time, what we can do is I'm going to save all the questions. I have the names of all of you, and we will answer to your question after the meetup. So thanks to you everyone for taking part in this meetup. So the replay will be available on our YouTube channel. I hope in the next 48 hours, and we will send you a link with the replay. So again, if you have questions for Peter and Pierre, and Francis, please feel free. We are sharing the mail addresses. And rendezvous next week on Tuesday, same time slot, for a new meetup dedicated to decision optimization with Alec Fisher. So I hope you enjoy this meetup, and I wish you a good end of day, or a good day if you are at the other side of our nice blue planet. So thank you all, and bye-bye. Thank you.
Thanks. Bye-bye.